Hello everyone, welcome back to NEETAtomix. This is your new faculty for chemistry, Bhishma series. Today we will be discussing the introductory points of chemical equilibrium. The points to be covered are equilibrium state, irreversible reactions, reversible reactions, and types of equilibrium. Starting is irreversible reactions. So what are irreversible reactions? Irreversible reactions are the reactions which proceed only in one direction, that is from reactants to products. They proceed from reactants to products. Reactants to products, and the products cannot be converted into reactants. These are called irreversible reactions. So, you might be wondering what are the examples of irreversible reactions. All the thermal decomposition reactions means the reactions which decompose in the presence of heat are called thermal decomposition reactions. For example, decomposition of potassium chlorate 2KClO3 gives rise to 2KCl plus 3O2. These are thermal decomposition reactions which take place in the presence of heat. All the precipitation reactions are irreversible reactions, meaning if there is a precipitate formed such as AgCl, BaSO4 precipitate, AgCl is a white precipitate, right? So when you react sodium nitrate with sodium chloride, sodium nitrate silver nitrate, sorry, sodium nitrate not, with the sodium nitrate, silver nitrate with the sodium chloride, you get AgCl as the white precipitate, and the next one is NaNO3, which is an aqueous mixture. All the neutralization reactions are irreversible reactions. So what is a neutralization reaction? Neutralization reactions are the reactions between a strong acid and a strong base. To give salt and water are called neutralization reactions. For example, the reaction between H2SO4, which is the strong acid, and NaOH, we are taking 2 moles of NaOH to balance the reaction, which is a strong base. It will give you salt Na2SO4 plus 2H2O. These are called neutralization reactions. Next, all redox reactions and combustion reactions are irreversible reactions. So what is the meaning of redox reaction? The reactions in which both the oxidation and reduction takes place simultaneously, meaning the substance is getting oxidized and other substance is getting reduced. In the name itself, you are getting redox reactions. RED means reduction and OX means oxidation. So the example is SnCl2 for redox reaction plus 2FeCl3 gives rise to SnCl4 plus 2FeCl2. This is the example of redox reaction. And the combustion reaction, you might be knowing what is combustion reaction also. So 2Mg plus O2 gives rise to 2MgO. This is the example for combustion reaction. So let me revise everything. That all thermal decomposition reactions are irreversible reactions. all precipitation reactions, meaning where this in this example AgCl is the precipitate, which is the white precipitate. All precipitation reactions are irreversible reactions. All neutralization reactions are irreversible reactions. So what is neutralization reaction? Reaction between strong acid and strong base to give salt and water is called neutralization reaction. All thermal decomposition reactions and the combustion reactions and redox reactions are neutralization reactions. So we will be moving to the characteristics of irreversible reactions. The reaction which moves only in one direction, that is from reactants to products, as I said you already. These are called irreversible reactions, and these irreversible reactions can take place in the open vessel only. The products do not react again to form the reactants. Change in concentration, pressure do not change the direction of the reaction. If we change the concentration of the product, pressure or temperature, it will do not change the direction of the reaction. Next we will be proceeding to the reversible reaction. So the reversible reactions are the reactions which convert from reactants to products and from products to again reactants are called reversible reactions, meaning they take place in both the directions, in the forward direction as well as the backward direction, bidirectional. Forward reaction takes place from left to right and backward reaction takes place from right to left. For example, if we consider a reaction of type A plus B gives rise to C plus D. So what is the forward reaction in this reaction? A plus B C plus D. This is the forward reaction. Forward reaction. I'm new to this channel, so that please excuse my writing and everything. This is the forward reaction. The next one which we are writing is the backward reaction. So the backward reaction is the reaction in which the products become the reactants. C plus D gives rise to A plus B. This is the backward reaction. So now we will be learning the characteristics of reversible reactions. In these reactions, the reactants give products. Sorry. In these reactants, the reactants give products and the products give you the reactants. Means they convert interconvertibly and they are always carried in the presence of closed vessel. Because if there are gases in the products and they want to be converted into the reactants, they have to be in the presence of closed vessel so that they react simultaneously and the reaction never goes to completion. There is a dynamic equilibrium established, but there is never completion of the reaction. They are characterized by the establishment of equilibrium and the reaction occurs in both directions. The irreversible reactions are unidirectional, but the reversible reactions are bidirectional. These are bidirectional. And you might also get confused between the examples of irreversible reactions and reversible reactions. So the examples of reversible reactions are the reaction between gases in a closed vessel, because the gases do not evaporate. If they are kept in an open vessel, they evaporate easily and the products are not converted into reactants. But in the presence of a closed vessel, the products, gaseous products are converted into a reactants. And thermal decomposition reactions are reversible reactions. So I will write the examples in the next place. Reaction between gases in a closed vessel. For example, if we take dinitrogen plus 3H2, it will give you 2NH3 plus X kilocalories. This is the heat. This is the heat. Next, thermal decomposition reactions are reversible reactions which take place in the presence of a closed vessel. For example, if we consider the reaction of PCl5, and it will give you PCl3 plus Cl2. PCl3 and Cl2 are both gases. So if they take place in the presence of a closed vessel, it will give you PCl5. Closed vessel is the important condition of the reversible reactions. Now, the reversible reactions are categorized into two different types of reactions. So, reversible reactions. The first one is homogeneous reactions. Heterogeneous reaction. So what are homogeneous reactions? Homo means similar, right? Homo, similar, same, homo. The reversible reactions in which only one phase is present. Here only one phase. Only one phase. Only one phase is present. That is, all the reactants and products are in the same physical state. For your simplification, I will give you explain with you an example. H2 plus I2 gives rise to 2HI. So here dinitrogen is a gas, diiodine is a gas, and 2HI is also a gas. So the physical state is always present in this present same in the homogeneous reactions, but it is opposite. The heterogeneous reactions are opposite to homogeneous reactions. The reactions in which more than one physical state is present. For example, let us take a simple example. Magnesium carbonate MgCO3 gives you MgO plus CO2. Here magnesium carbonate is a solid, MgO is also a solid, and CO2 is a gas. The physical state of the reactions, not only the reactants, but the physical state is different in the reactions. MgCO3 is a solid, MgO is a solid, but CO2 is a gas. But in the homogeneous reactions, H2 is a gas, I2 is a gas, and 2HI is a gas. For today's class, we have discussed, I will give you a short recap of this today's class. Quick recap. Firstly, we discussed about irreversible reactions. Irreversible reactions. So, what are irreversible reactions? The reactions which convert from reactants to products only. That is the reactants which occur unidirectional. These are unidirectional. Unidirectional. But reversible reactions are bidirectional. What are the examples of irreversible reactions? Thermal decomposition reactions, precipitation reaction, neutralization reaction, and redox and combustion reactions are all the examples of irreversible reactions. But reversible reactions are the reaction of gases between gases in a closed vessel are called reversible reactions. The important term for reversible reaction is closed vessel. They occur in the presence of a closed vessel only. That is, they don't occur in the presence of an open vessel because gases evaporate and the products are not converted into reactants. So, thermal decomposition reactions in the closed vessel are reversible reactions, and the reaction between gases in a closed vessel are the examples of reversible reactions. The next one is homogeneous reactions. Homogeneous, the reactions in which only one physical state is present. One physical state, only one physical state, either gases or solids. All solids, all gases, only one physical state. But in heterogeneous reactions is the reversible reactions in which more than one physical state is present. Homo, hetero means more than one. More than one physical state. PS means physical state. That's we have to learn about the definition of chemical equilibrium also for today's class, and this is the last topic. Chemical equilibrium in a reversible reaction is a state at which the concentration of the forward reaction is equal to the concentration of the backward reaction. Means that the both the forward reactions and backward reactions occur at the same speed. So we will represent it graphically. This is the rate of forward reaction. When the reactants being converted into products, you might be already learnt in your chemical kinetics, the rate, the concentration of the reactant decreases, but the concentration of the products increases. So this is the rate of backward reaction and forward reaction. There is a state at which both the reaction rates become equal. Means the rate of forward reaction is equal to the rate of backward reaction. And the stage of reversible reaction at which the concentration of the reactants and products do not change with time. This is called equilibrium state simply. Next class we will learn about the characteristics of equilibrium state and the law of mass action and expression of Kc. Thank you. Today this is my first class. Sorry for the inconvenience caused. Tomorrow I shall promise you to explain you better. and thank you. Please subscribe to the channel. If you like the video and then subscribe. It takes only 2 seconds for you. Yeah, thank you.